All right, so I guess we're going to start this course in the chapter on functions, and I'm sure this is probably pretty familiar to you. I'm sure you've seen functions before in your algebra classes, um, but it's always good to kind of review that and get a little bit better foundation and understanding for these things that essentially we're going to be studying the whole semester. Um, we'll be studying different types of functions and different things we can do with them. And so it's very important to understand basically what a function is before we even get into the specifics. Um, so we have a few examples here, and we could look at height as a function of age, and all this means is, and we'll look at a formal definition, but um, if we have a particular individual, um, given their particular age, they will be a particular height at that particular age. Or we could look at temperature as a function of date. On a particular date, there will be a particular high temperature in this case. Obviously, during the day, the temperature fluctuates, so we maybe look at different times during the day. Um, but given a date, in this case, we could have a particular high temperature. Or we could look at postage as a function of weight. And so in this case, it's a little bit different. So here we have a range of weights. So from 0 to 1 ounce, the postage would be 98 cents. From 1 to 2 ounces, the postage would be 119. So it's not like this where it's going up or down depending on the date. This case, it is one particular dollar amount for a range of weights, and then when we get past one, it's going to bump up, and when we get past two, it's going to bump up again, and so on. So these are just examples of functions. The term function describes this dependence of one quantity on another. So other examples, we could look at the area of a circle. Given a radius, we can find the area of a circle. The number of bacteria over time. So the number of bacteria will grow as a function of time. Weight of an astronaut is a function of elevation, or the price of a commodity um, based on the demand. So if we want to get more formal with functions, a function is a rule, and f is the name of the function that we could use. A function is a rule that assigns to each element x in a set A. So we have a set, just a collection of values that we're going to name x. Um, for each x, we're going to assign exactly one element in another set B. So we have a collection of elements in a set A. We're going to take each of those elements in A and assign them to an element in B. And so the symbol f of x. So this symbol, f parentheses x, we would read that f of x. And this value is the value of the function at this particular value of x. And so the set A is called the domain, and then the range is all the set of all possible values of f of x that we could get. We'll talk more about those as we go along here. So we can also use diagrams. So here we have an example of what would be a function. Here we have one that is not a function. So in the function, each of these in set A, or each of our x's, goes to exactly one element over here. And we could have two that go to the same element. So for example, 1 and 2 both map over to 20. But the important part is that 1 only maps to 20. It doesn't map to 20 or 30. Whereas in this case, we have 2 maps to 20 and then 2 maps to 30. And so that means it's not a function. So for it to be a function, for a set mapping to another set to be considered a function, you can only have one element over here. You can only have an element over here going to exactly one element over here. It cannot go to 2 elements. So here is a function. Here is one that is not a function. All right, so let's look at an example here. So a function f is defined by the formula f of x equals x squared plus 4. And so this one is indeed a function. And so let's just find some values, and you've probably have seen this before. So let's find f of 3, we'll find f of -2, and we'll find f of square root 5. And so all of these are valid numbers that we could plug in for x. So f of 3, we're just going to plug in 3 for the x, and we get 3 squared plus 4, and now we can simplify that, which is 9 plus 4, and then we get 13. So f of 3 equals 13. And so we could also say that the ordered pair 3, 13 is a point on the graph of this function. Now we do the same thing with -2, so we're going to plug in -2 for x. We have -2 squared plus 4. -2 squared, of course, is 4. 4 plus 4 is going to be 8. So f of -2 is 8. And again, we could say that -2 comma 8, the ordered pair -2, 8 is a point on that graph of this function. We could do square root 5. So plug in square root 5 for the x. Square root 5 squared, that's just going to leave us with 5 plus 4, and that is 9. And so f of square root 5 is 9. It's a very, very basic. Anything that we have in the parentheses here, we're going to plug it in for any of the x's that we see over here. And we'll of course see functions later on that have multiple x's. And in fact, this next one does. We're not going to do much of this. This is just more of, we're going to kind of explain evaluating functions. So the independent variable x. So x is always the independent variable. It can be whatever it wants to be. And then y is the dependent variable, and it's dependent because it depends on the value of x. So, so this here, f of x is going to be equivalent to y. We can kind of use them interchangeably. So this y value depends on whatever the x value is. So here are our inputs. So 3x squared plus x minus 5. So we're just replacing the x's with boxes. We can replace this with anything. So if we put a b in there, we put a b in there, we put a b in there. You could also put, you could put something more complicated. You could put in x plus a in here. And then you put x plus a in that spot and x plus a in that spot. But you can put in whatever you want, whatever the input is, whatever number would work. You can put in any number in this spot. So these are really just, we have an x here. That's just a placeholder. You put in whatever you want, as long as it is part of the domain of the function. And we'll talk about domain probably in the next video. So let's look at a couple more examples. We'll use the same function, and it should be a plus. So let's find f of -2. So we're just going to plug in -2 for the x. And simplify. So we have 3, -2 squared, of course, is 4. This would be -2, minus 5, 12, and then we'll go ahead and combine these. We get -7, and that is 5. So f of -2 equals 5. F of 0, plug in 0 for x. And of course, these are going to be zeros, and we get -5. So f of 0 is -5. F of 4, we're going to plug in 4. Get 3 times 16 plus 4 minus 5, so that's 48. Minus 1, so that's 47. So f of 4 is 47. And then last f of 1/2, so 1/2, 3 times 1/2 squared plus 1/2 minus 5. 1/2 squared is 1/4. And then 1/2 minus 5, that would be minus, so 1/2 minus 10 halves, that'd be minus 9 halves. And 3 times 1/4 would be 3/4, minus 9 halves. And so let me get a common denominator here. Common denominator would be 4, so this would be 18/4. And so 3 minus 18, that is negative 15 over 4. Of course, you get a scientific calculator. But I mean, you should be able to add and subtract fractions, no problem. Um, all right, so we'll go ahead and stop this one, and we'll finish up this section in the next video. We'll try to make these videos 10, no more than 10 or 15 minutes, but 10 minutes would be ideal. So that way you can kind of see the parts that you need to see and not have to search through long videos. So we'll pick it up on the next one.